Hello students, welcome to Inside Physics. I am Srinivas. Today we are going to discuss about cells, that is batteries. So in our current lesson, this current electricity, see I am going to explain about cells and their EMF, that is electromotive force, and their internal resistance. So, in cells, what kind of cells generally are used? See, generally, an electrolytic cell and a dry cells are used commonly for the purpose of generating some potential difference across circuits, or generally if you see in our home appliances we use some battery in for in an inverter, okay, when the power is off in our homes, okay. So here, what is a cell? Here we discuss generally about electrolytic cell. See, an electrolytic cell which is having an electrolyte in a container, and here there are two adjustments for two electrodes which are dipped in the electrolyte, okay. See, a cell produces the necessary EMF, that is electromotive force, thereby creating some potential difference across the circuit which it is connected. Okay, the potential difference obviously generates some current flow in the circuit. Okay, so it is an external appliance which produces some current, required current in the circuit, and we will see how the cell, an electrolytic cell, is working here, and we will discuss the EMF and internal resistance of the cell. Okay, see, this is an electrolyte, okay. See, an electrolyte is a good conductor, and it is having a free positive and negative ions which can conduct the electricity. See, in a conductor there are free electrons that move, and they will carry the charge by having the current flow. And here in an electrolyte, it is the positive and negative ions that carry current, and this positive and negative ions in the electrolyte are the responsible for conducting electricity in the electrolyte. Okay, see, this is the positive electrode and this is the negative electrode, and these two electrodes are generally metal rods which are dipped into the electrolyte. And here, see, the EMF of the cell generally defined as the potential difference between these two electrodes, okay, the potential difference, that is called EMF. Generally EMF is used, the term is used in olden days, in where when the correct meaning of EMF is not properly understood, but the actual meaning is the difference between the potential difference between electrode P and electrode N. So here, if you observe, in an open circuit, that means if there is no current flowing in the circuit, suppose this is the resistance R that is connected to the electrodes, that means if you consider this as a circuit, and in the circuit there may be some resistors, some cells, and in complicated circuits we may have n number of resistors, capacitors, and cells. Now for simple understanding, in this circuit we have connected a resistor of resistance R, and we have taken an electrolyte in which two electrodes are dipped in the electrolytic solution. Okay, so with Ohm's law, the current flowing through the circuit, we can write it as V is equal to IR. This is the resistance. So in an open circuit, for an open circuit, or if we take the resistance as infinite resistance, that means I is equal to V by R, the current will become 0. See, if the resistance is infinite, or if it is an open circuit, that means no current is extracting from the battery, that is called, then in this situation the EMF of this cell or battery can be written as, see, EMF is equal to the potential difference between P and A, and the potential difference between A and B, and the potential difference between N and B. The sum of potential differences of these three: potential difference between P and A and B, and N and B. So here, in when the electrode is dipped in the electrolytic solution, these electrodes exchange charges with the electrolyte. Okay, exchange charges with the electrolyte. See, this positive electrode will be accumulating the positive charge. That means it will give back the electrons to the electrolytic solution. These electrons are accumulated at the negative electrode. So if you take the current direction, see, this is the electron direction in which the electrons are flowing from negative electrode through the circuit, and we generally consider the current direction as opposite to the electron flow, and we can mark the current direction in this way in this circuit. Okay, so see, this is the current direction and the electron flow in this way. Okay, so when the electrons are moving in this direction and coming here, again from this electrode the electrons will be moving to the electrolyte, and they are moving to the negative electrode, and they again move to the circuit. So this is the flow of electrons, and against the flow of electrons we take the current direction. Okay, okay, we need to have this direction. Okay, see, this, because of the exchange of the charges, the electrodes will develop some potential on them, and we can write the potential of the electrode P as, see, V plus potential of electrode P, we can write it as V plus, and it will, the negative electrode will develop a negative potential, and we can mark it as minus V minus. Okay, so this will develop a negative potential, this will be a positive potential, and we just now we have discussed that the electromotive force EMF of the cell is nothing but the potential difference between the electrodes P and N. That means we can write Vp minus Vn is equal to V plus minus of minus V minus, that is equal to V plus plus V minus. Okay, so this is the EMF of a battery connected to the electrodes P and N, and which is connected in a circuit, right? So this is the EMF of the battery when no current is extracting from the battery, that means the in an open circuit. Okay, see, we are not using any current from the battery, and the here R, we can consider this R as infinite resistance, so that no current is allowed through this resistance. Okay, so now if for infinite resistance there is no current, for a finite resistance we have put some R as a finite resistance, and we have taken the value for R. Now what happens to the EMF? See, if we are having the resistance as R and the current is flowing through R, and actually it is allowed, now the current is flowing through the circuit. If the current is flowing through the circuit, and it will again go through the electrolytic solution, the flow of electrons. So the current is also passing through the electrolyte. Okay. Now when the current is passing through the electrolytic solution, the internal resistance R of the electrolyte will come into picture. Okay. Now this is considered as epsilon EMF of the battery, and this is equal to, we already discussed, see, this V plus is the potential difference between P and A. This V minus is the potential difference between N and B. In this case, this can be, we can write this as potential difference between P and A. A is a point taken near to the electrode which is lying in the electrolyte. Okay, and B is another point near to the electrode which is lying in the electrolyte. So the potential difference between P and A plus potential difference between A and B plus potential difference between N and B. Potential difference between N and B. Okay. So the potential difference between P and A is V plus, and potential difference between A and B. Okay. When there is no current in the external circuit, that means in an open circuit, the potential difference between A and B is 0. So potential difference between N and B is minus V minus. Okay. So this is considered as the EMF, that is equal to EMF in an open circuit. Okay. Now what happens when we allow the current by considering the R as finite resistance, so that the current is also flowing through the electrolyte. Okay. See, if the current is flowing in this direction in the circuit, okay, and here in the external circuit the current will is flowing from P to N, and in the electrolyte the current will flow from N to P, right? In the external circuit the current is flowing from P to N. In the electrolyte the current is flowing from N to P. Okay, so that is why here the EMF, the epsilon EMF of the battery can be written as, in case of a open circuit, okay, this is IR. Okay, I is the current flowing through the electrolyte and R is the internal resistance. This is the net EMF when the circuit is connected and if current I is flowing through the circuit. That means in an open circuit it is actually the original EMF of the battery that is actually stipulated for the battery, and in an external circuit when it is allowing the current in the circuit, actually the potential, the EMF of the battery generated is not exactly the stipulated EMF of the battery. So some force, electromotive force is wasted because of the internal resistance. See, in the internal resistance of the battery, so the electron flow is having some obstruction in the electrolyte also. So in this way some electrical power is wasted inside the battery, and that is the potential difference in the battery is, with Ohm's law we can write it as the current flow into the internal resistance of the battery. So in this way we can identify the EMF, electromotive force, or potential difference between the two electrodes in an open circuit and in a closed circuit. Okay, overall, see, this EMF, the force with which the electrons are pushed towards the circuit, which makes the electron flow in the circuit, is the chemical force which is there because of the potential difference developed across the positive and negative ions in the electrolyte. The chemical force actually pushes the electrons through the circuit, which is allowing a current pass through the circuit. So here the chemical force is used as the electromotive force, which is pushing the electrons through the circuit. Okay, see, generally, normally we don't consider the internal resistance of the battery in practical conditions, because here, see, electromotive force is far greater than the potential difference in the cell. Okay, so for this reason, in practical purposes we don't consider the internal resistance of the cell. So in dry cells, generally the internal resistance is very high in dry cells compared to the electrolytic cells generally used in for common purposes. Okay, so with Ohm's law we can write, see, in this external circuit connected to the battery, with the help of Ohm's law we can write, see, V is equal to IR. Okay, V is equal to IR, and in with the circuit connected to the battery we can write the equation for the cell as epsilon is equal to V is equal to epsilon minus IR. Okay, so if you consider this IR is equal to epsilon minus IR. Okay, so this one, if you take this term to the right side, it will have IR plus V is equal to IR. So in this way we can write the potential in an open circuit considering Ohm's law, and by that we can have the electrolytic EMF comparing to the Ohm's law. So this is the details about electromotive force and the internal resistance of the battery. Okay, in the next class we will see some more topics in current electricity.